All right, this is the second half of Unit 4, Lesson 9. We're doing a little bit of a different task. Last time I gave you a couple of transformations and a composition. Now I'm giving you the pre-image and the image, or the object in the image, and I'm asking you to come up with, or we're going to come up with, a series of steps of composite transformations that map A, B, C onto A prime, B prime, C prime, thus proving that A, B, C is congruent to A prime, B prime, C prime as long as we execute only rigid transformations, not including any dilations, which would cause a change in the size of the image. All right, so let's go ahead and see what we can do. Let's think about this a little bit. Remember our transformations. We have rotation, reflection, and translation. That is flipping, spinning, and sliding, right? And so we can't simply slide the green triangle onto the orange triangle. But it looks to me like if we take the green triangle and move it down and rotate it, we could get it to match. Now we can do the rotation and the translation in two separate steps. I could translate it first and then rotate it. That would be a little bit tricky, but it would be doable. Or I could rotate it first and then translate it. And that goes to the idea that the order of transformations, though important, can vary. You can change the order of the transformations and get them still to work. So I'm going to rotate this thing. Okay? And the way I'm going to rotate it, I'm just going to rotate it visually. I'm going to rotate it 90 degrees clockwise. So the A, 90 degrees counterclockwise, I should say. The A is going to go down over there somewhere, right? But the key to use the numbers 1 and 2, 4, 6. So 2, 4, 6, and negative 1. There we go. There's our image, and let's change the color so it's not the same color here. So 2, 4, 6, negative 1. Okay. So that's after rotating. Okay, same idea, rotating 90 degrees. So 90 degrees, remember we're going to switch the order here. So this is 2, 4, 5, 2, 4, 6. So we're going to go 2, 4, 6, 2, 4, 5. Okay, and there we go. And then C is left 2, 4, 6, 8, 10, and up 1. So we're going to go left 1 and down 10. 2, 4, 6, 8, 10. Okay, kind of doing a 90-degree rotation on C, 90-degree rotation on B, and 90-degree rotation on A. And I undid my point here. So 2, 4, 6, 8, 10. Okay? So that's the results of the of the rotation. Okay, let me go ahead and draw the triangle. And now we've got it to the right orientation. And now we need to slide it, right? I'm going to slide it to the right and up. Okay, let's go ahead and change colors again. Okay, we're going to go to the right and up. So this point right here is going to go to the right 4, and up 3. Okay, up 3, resulting in the vector 4, 3. 4, 3. So this is the vector 4, 3. Okay, and we're going to apply that vector to all the points. So here are the steps. 1, I'll just write it over here. 1, rotate 90 degrees counterclockwise, which is positive 90 degrees. 2, translate right 4 and up 3, or by the vector 4, 3. Okay, those rules are, you recall from your rules, xy becomes negative yx, and 2, xy becomes x plus 4, y minus, or y plus 3. Okay. Now to create the composite transformation, we're going to take what became x and plug it in right here, and what became y and plug it in right here, right? So we're going to go negative y instead of x plus 4. We're going to go x instead of y plus 3. And so this is our composite transformation. xy becomes negative y plus 4, x plus 3. Let's go ahead and see if this works. Let's try it for a. A is at negative 1, 2, 4, 6. Negative 1, 6. So let's try negative y, negative 6 plus 4. X is negative 1 plus 3. Okay. And negative 6 plus 4 is negative 2. Negative 1 plus 3 is 2. So negative 2, 2. There it is. There's A prime. V prime, or V, is at 2, 4, 5, 2, 4, 6. Negative 5, 6. So plug it in. Negative y plus 4 is negative 6 plus 4. And at x plus 3, so negative 5 plus 3. Okay, negative 6 plus 4 is negative 2. Negative 5 plus 3 is negative 2. So negative 2, negative 2, there's V prime right there. And C, so that's C prime. C is at negative 10, 1. Okay. And let's plug it in. Negative y plus 4 is going to be negative 1 plus 4. And x plus 3 is going to be negative 10 plus 3. Okay, so we get negative 1 plus 4 is 3. Negative 10 plus 3 is negative 7. So 3, negative 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. There it is. Look at that. That's C prime, and this was V prime, not C prime. Okay. All right, so it worked. It worked. We started with a image and a pre-image, and we came up with this composite transformation that mapped it onto it, thus proving, by the way, that ABC is congruent to A prime, V prime, C prime, because we executed a rotation, which is a rigid transformation, and a translation, which is a rigid transformation. Rigid transformations always produce congruent figures.